So we're finally onto our last group of organic compounds, which are alcohols. Okay, and you looked at a wee bit at this at GCSE, but we're going to look a bit more in detail at them and how they react, etc. But as I said earlier, no mechanisms in this topic, so hopefully it should be a wee bit quicker than the other ones. And so alcohols, yes, you met them in GCSE. You would have learnt their general formula. I know it's there, but can you remember it?
OH minus.
Pardon?
Sorry, that's it on the left.
Yeah, you do. C.
CaHL plus O minus. OH minus.
It's not on the board.
Plus OH minus. All right.
CaHL plus 1OH.
Use that. Did you need your hole to escort you?
Your what? Your hole? Oh, I think that's hole.
I love how you and was included in that.
Okay. And again, I don't really learn these general formulas, to be honest. What I would say is remember, like, ethanol. I just remember ethanol is C2H5OH, and you can kind of work out your general formula from that. You know that if you know the general gist of it. But you probably should learn that. Now, just says there sometimes it is written as just R-OH.
Josh, you better pick that up.
Again, where R is an alkyl chain.
Not a bin.
So R is our alkyl chain, so methyl, ethyl, propyl, butyl, and OH we call the hydroxyl group. Hydroxyl group. Think hydroxide ion, hydroxyl group. Okay? So take some time and put some molecular formulas in the table and draw out the structural formulas too. See if you can do this in 3 minutes. Do note that if you are asked to draw the structural formula, the full structural formula for an alcohol does show that bond between the oxygen and the hydrogen. So for example, for methanol, your molecular formula should have been CH3OH. And your full structural formula should be, there's your CH3 group, and then oxygen and hydrogen. That's technically your full structural formula. Now, is that going to be the shape of our hydroxyl group? No. So how do you think I should draw my hydrogen?
The hydrogens are going to move towards the bottom, like they're going to fill.
They're going to go. Okay. So, draw it.
Yeah, but when you throw in the H, it's not messing around.
So like that, as in like water.
Oh my.
So imagine, what is making my hydrogen go there?
The
The lone pairs on the oxygen.
So do we have to draw this like that?
Okay, so in the full structural formula, okay,
Just call it Carl. No, it's not here, right? Paul. Oh yeah, Paul, sorry, yeah.
the full structural formula, what I'm just saying is that you should draw that bond between the oxygen and the hydrogen in the full structural formula. If they ask,
should not be like this, then you.
if they ask for the full structural formula, technically the carbon we should draw as a tetrahedral arrangement around the carbon. No, what I've done there is.
So if they ask for the structural formula, we draw that, will we get it wrong?
Yeah.
Instead of
Like,
straight
Is this
on.
still
No, you wouldn't get it wrong if it was fully straight.
No, but should not be like this.
The whole point of the full structural is that you show that bond. No, yeah, Oisin, I'm answering you now. So think about water. It's that shape is what you're saying to me.
Aye.
But I could also rotate that. Hopefully I can just rotate that.
Alright, yeah. Oh, so it is like, you could have said yes.
See?
Let you off this now.
Okay, thank you very much.
I've decided not to go to after school supervision.
So when it comes to naming alcohols, how we name them is as closely related to alkenes, I would say, more so than halogenoalkanes. So, for example,
Did we not already naming alcohols up on stage?
nope.
It's not all the same though, anyway.
What is the name of this?
I don't know.
Actually, hold on. We don't need a number there. So hold on.
One bromo propane.
1 bromo propane. Okay, now can you see that that number comes before the whole name of the molecule?
I can.
And that's because the bromo part of it is less of a priority than the alkane part of it. Don't worry too much about that. What then is this called?
Mescaline.
Hold on. That's going to be in every video. Pardon?
Propylene.
Probe.
Victoria, I remember what it is now. You have to pretend to be like a wee French girl. So I think it's a French person. And it's on.
With our alkenes, we now put our number between the name of our carbon chain. So it's prop 1E. Okay, so alcohols are like that too. So for example, let's keep with the prop example. My alcohol group could be there. It could be there. Or it could be there. Okay, if I leave it there. Good. So we put our number between the name of the carbon chain. So again, we have to find our longest carbon chain. All the same rules that way. Okay, but we put our number in between the name. Put the number in between the name. So it's propan 1O. And you'll notice that with our alkenes, it wasn't propan 1E, but it's now propan 1O. Another way it is.
It's
not that difficult, actually.
The other way it's similar to naming alkenes is, if you remember with alkenes, if we had one double bond, that's fine. So say but 2ene. Remember we talked about if we have. But say now, rather than just one double bond, we have two double bonds. Remember we talked about how we need to change the name slightly. This is now but. Nope.
Three.
No, butane 1, 3.
3.
1, 4, 1, 3. Sorry, yeah, you're right. 1, 3. What's the end of it?
All.
No. What sort of substance is this? Dying. But what do we need to add before the numbers? An A. So remember, it's buta 1, 3 dying. That's just the rule. If there's two double bonds, then we change it from like BUT to BUTA. And that's what I'm saying. With alcohols, there's a similar rule in that if I have two alcohol groups, so if I have two hydroxyl groups, then it changes its name slightly. So let's do an example of that. So for example, if I have okay, what's this called? Propan. And I need a number because it could be on carbon 1 or carbon 2, so it's propan 1O.
What? But do you know how to say something so you know it's an OH?
There's no double bonds. Why would you put a number in?
All.
Oh.
There's not always propanol for anything. Oh, it's propane.
For example, we can change it to, oh, not this. So what is this called then? James, what is this called?
It's going to be propan 2O.
Good, so there's your longest carbon chain, number them, so that your alcohol group is on the lowest carbon. Just the similar rules, I'm just pointing out the ones that are like a little bit different.
I get this.
So propan 2O. But what we're talking about there is if we have two hydroxyl groups. So if I now have, let's do it in pink.
I would in pan.
That's just the way it is. You know, like propane. I'm just taking off the E and putting an O
Not like
on.
propal.
Nope.
Propal, yeah, it doesn't really sound right. Propal, propal.
Okay, so what is this called now?
Exo, James, no, is it like diol?
Propan.
Diol or something?
1, 2, diol. But just like in alkenes, the way we have to add an A in. In this one, we don't do an A, but we do an E. So it's propane 1, 2,
So why
diol.
would you add an E or an A?
If there is 2 of the functional groups. So where there's 2 double bonds, it's buta 1, 2 diene. With this, with an alcohol where there's 2 hydroxyl groups, it's propane 1, 2 diol. Okay, so that is point number 5. So if you want to put a star at number 5, that is important. Anything else, like if I have methyl groups on it, ethyl groups, bromo, chloro, again, they're just added onto the front like they normally are in alphabetical order, same as all our other rows. But the one point I then want to, if you look at point number 2, actually look at point number 1 first of all, or the note number 1, so then the notes underneath the 8 numbers. Okay, you don't need, pardon? Yeah, I did. If it's methanol or ethanol, we don't need a locant number or a positional number because it can only be on the first carbon. It can only be on carbon number 1. So with methanol, there only is 1 carbon, so I don't need to call that methan 1-ol. And the same with ethanol. It doesn't matter which way I number it. If I number it 1, 2, that would then be wrong because I have to number my carbons so that my hydroxyl group is on the lowest number of carbons. So I need to number it 1, 2, and so that's ethan 1-ol. But it doesn't matter because I could just flick that to the other side. But then I would number it the other way. I would number it the pink way. Okay, so we don't need a positional number where it's ethanol. Unless, what? When would I need a positional number with ethanol? If there's 2 hydroxyl groups. Brilliant. Okay, so that would be, what would the name of this be?
1, 2, diol.
Now remember our numbers are in the middle of it.
Yeah,
But ethane, good. 1, 2, diol. Brilliant. This is 1D, we'll have a look at. So, this is our molecular formula here. You've got 5 carbons, H11OH. You can see that it fits the general formula. Pardon? Yeah. Okay. And so, going through our rows, we find our longest carbon chain that contains the hydroxyl group. And we number the carbons so that the hydroxyl group is on the lowest carbon. So it doesn't matter which way we do this, but 1, 2, 3, 4, 5. So what is this called?
Pentane 3-ol.
Not pentane 3-ol, just pentan 3.
Where
Oh.
does the E come into it?
When we have 2 hydroxyl groups, when we've, yeah,
What one's
if we have
this?
more than 1. This is 1D.
What if you have
Why is
methyl
it a
group?
tan? Oh. I wrote pan. That's
You
the
wrote
third
propane.
one.
Okay?
Pentane.
So pentan 3-ol.
What if you have 2 methyl groups? Is it pentanol?
What do you mean? If you had
2 like methyl groups.
where?
In it.
It would be like if it was on position number 2, say here, I'm dropping pink. That would be,
Pentane.
well, I'll draw it.
Yeah, but would I make a pentane or not?
No, it wouldn't make it.
We have to have 2 of the functional.
It would be
Yes.
2 methyl.
I'm so
Pentan 3-ol.
hungry.
Okay. next one, this is 1J. So again, find our longest carbon chain that contains the hydroxyl group. You can do it a couple of different ways, but
I did it the wrong way.
okay. But notice, what do we have in this case?
Nope, I did it the right way.
We have 2 hydroxyl groups. So what do we need to call this? Great, pentane. Now we need to number our carbons, so we'll number them so that it's the lowest combination of numbers of that the hydroxyl groups are on. Because if we had numbered it this way, we would have 2, 5. But what do we have if we do it the right way? 1. Yeah, so it's going to end in pentane dash 1, 4 dash diol. But what else do we have? With methyl substituents. And what are they on?
2 dimethyl.
Yeah, great. But again, remember, talked about we need 2, 2 dimethyl to show that they're both on the second carbon. So 2, 2 dimethyl pentane 1, 4 diol. Crazy. Okay, and then this is example 2E. And so the easiest way to draw this is just by, first of all, looking at how long your longest chain is going to be and drawing those carbons in a straight line. So this is hexane, so it'll be how many carbons long? 6.
This where you got
Okay.
this question from?
This is
2E that I've said 3
Is
times.
it not methyl? Or no, it's ethyl?
I'm direthyl by 3.
But that's not going to be the end. Look at the end of our name for the length of our alcohol.
Number 2 says ethyl.
Great, this is 4 ethyl,
Yeah.
3, 5 dimethyl. Okay, so our longest chain is a hexane, so we have 6 carbons. And if we just number them, get from left to right, it's 1, 2 diol, so I'm going to have a hydroxyl group here, I'm going to have a hydroxyl group here, doesn't matter which side you do it on. 4 ethyl, so what is the formula of an ethyl group?
CH2CH.
Yes,
Or CH25 or CH5.
yeah, great, just do it that way out of simplicity. 3, 5 dimethyl, so a dimethyl group here, and a methyl group here. And then I can fill the rest up with hydrogens. Now, full structural formula, you should do those, first of all, you should do the alcohols as OH. So if I change that here, you should do it as OH. And the methyl group, you should technically do, the methyl and the ethyl groups, you should do as this. If you were asked for the full structural formula, you have to show every single bond. So if you could finish that off for Monday, so question 1 and question 2. So just like our halogenoalkanes, we have primary, secondary and tertiary alcohols. So again, it's just decided in exactly the same way. So a primary alcohol, you focus on your carbon that's connected to your hydroxyl group, the alcohol group. And if it is connected to 1 or no carbons, what is it going to be?
Primary.
It's going to be primary. So in this case, I've just got one, it's my central carbon is connected to 1 other carbon, so this is primary. But if it's connected to 2 carbons, then what is it called? Secondary. And if it's connected to 3 carbons, it's going to be tertiary. Okay, so exactly the same rules as with our halogenoalkanes. You're just looking at the central carbon, the one that's connected to the hydroxyl group and seeing how many other carbons it is connected to. But see, I actually give you definitions for these ones, so you may be asked for the definition of a primary, secondary or tertiary alcohol. So I've written those in there. So for a primary alcohol, they've written it as an alcohol which has only one carbon directly attached to the same carbon as the OH group. And you would know that to recognise, you would know that to draw, but just that's it written out in sort of word form if they were to ask you for it. Okay, so we've got some examples of primary, secondary and tertiary alcohols here to look at. So the first category we'll look at is primary alcohols. And the first example there is ethanol. Okay, and so I want you to draw the structure of ethanol above where it says ethanol. Okay, and you can see that our central carbon here, the one in blue, it's the one connected to our hydroxyl group. It only is bonded to only one other carbon, and so that's a primary alcohol.
Would you get that wrong if you put the dash between the old H?
No,
Okay, cool.
that's the best way to draw it in terms of structural formula. We'll do it that way. Generally it's just drawn as OH, but if you were asked for the full structural formula, you need to show every single bond, and there's just one bond between our oxygen and our hydrogen. No hydrogens. Okay, next example is butanol. And you'll notice with all our primary alcohols, they'll all end, it'll always be butanol, propan-1-ol, because they have to be on our first carbon. So we've got 4 carbons, hydroxyl group at the end. And then what is methanol going to look like? What does meth mean? Yeah. 1 carbon in the middle. So it's kind of like methane. So methane would be CH4. But we have replaced one of the hydrogens with our hydroxyl group. So this is methanol. That's an example of a primary alcohol. Okay, then our secondary alcohols, they're connected to 2 carbons. So, for example, we've got propan-2-ol there. So, 1, 2, 3. Hydroxyl group is on the second carbon. So I want to look at my central carbon, the one that is connected to the hydroxyl group, and it's bonded to 2 other carbons, and so it's propan-2-ol. And you can draw in butan-2-ol and 3-methylpent-2-ol. Butan-2-ol is just going to be propan-1-ol with an extra methyl group at the end. And 3-methylpent. I can't really see it, but I think so, yeah. So we have our hydroxyl group on carbon number 2, and then a methyl group on carbon number 3. And hydrogens everywhere else. Again, our central carbon is connected to 2 other carbons, so that's why it's a secondary. That's 3-methylpent and 2-ol. Then over the page, you can see we've got our tertiary alcohols, And again, I've got our CA definition there, an alcohol which has 3 carbons directly attached to the same carbon as the OH group. And 2-methyl-propan-2-ol. Should look like this. You can just check this is what you've drawn. And if you want to just highlight in some way that that's connected to 3 other carbons. And 3-ethyl pentantiol. You find that?
I'm not going to start pissing.
And that's our structure of 3-ethyl pentan 3-ol. If you want to check that. Because that's our ethyl group.